People trickling in, but we'll get started here in a couple minutes. Just going to give everybody a chance to get in. All right. I just wanted to ask the room, I know many of you may have heard of BrainSpace, but I'm curious to know how many people have actually seen the product before? Okay. How many people have seen the most recent version? Oh, cool. All right. Nice. I've been in here for like the last 8 months, 9 months, so it's not as new to me, but it's still cool. So really the premise of this presentation is really going to be a feature demonstration at its core, but I'm also going to talk about, at a high level, the workflows we've developed that really are all about taking what we do and applying it to real market problems, specifically around investigations, the different types of investigations, and accelerating review. So these workflows we developed as sort of a baseline or a standard to help our users really leverage the technology. For a long time, we had just sort of been saying there are all these cool things you can do with the technology. Basically, any use case that called for disambiguation of large amounts of unstructured content, there was a use case for BrainSpace. As we've developed out the visuals and as we've built the supervised machine learning component into the interface, we really realized very quickly that there were very specific things that could be done. Of course, we work harmoniously with Relativity, and the integration is very tight. And all the things that you can do in BrainSpace can be leveraged on the review side. I jumped right in and didn't even introduce myself. My name's Naz. I work on the solutions architecture team at BrainSpace. And really our primary focus is to, again, help people leverage our technology. It's one thing to have all this cool stuff, but if it's not actually doing, solving real problems, then there's a question as to whether it's valuable. And we've, over the last 18 months, spent quite a bit of time realizing and helping people realize we've got a lot of really great success stories, things that people have been able to find, and just ways that they've been able to look at the data that just wasn't possible before. So the workflows we'll start with after I talk about really at a high level what BrainSpace is, what it does. And we came up with this really kind of a high-level description of the product to help people articulate when they have to sell it or talk about BrainSpace, what it's doing. So at our core, it's a combination of algorithms. But people think of BrainSpace really as the user interface. User experience is something we live and breathe. So all of these algorithms that we're using are great, and they're powerful. But if people can't approach the technology, then how valuable is it? So we start with our cutting edge visuals, and they're all about ultimately finding the signal in the noise. If you've got a lot of things to go through, ultimately read, BrainSpace is powerful in helping you find the signal in the noise. So dynamic visual analytics really are sort of the main focus of the product line, but 2/3 of what we do is behind those visuals. So we've got algorithms we use for both unsupervised machine learning. What we call our brain is leveraging technology that's ultimately finding patterns in unstructured content, and that's how we are able to leverage concept search. And then we also have algorithms we use for organizing documents based on lexical similarity, and we bring those two things together in a really cohesive way. And then ultimately the story we've been telling lately is supervised machine learning, which is driven by continuous multimodal learning. So it's a feature. There's a number of different workflows that you can use with that feature, but ultimately it's about taking this idea of building a supervised machine learning model, basically a predictive model, and making it very easy to build that dynamically. So based on any tags, at any point in the workflow, you can start building a model. You can start building a model with as few as one document, ultimately. So that's really a powerful feature set that we've built out, and we've started to incorporate really language around how to apply it in different ways, how to start leveraging it immediately. And the nicest thing about these workflows is they're completely non-disruptive. So really, if you're not using supervised machine learning, what we're trying to do is make it easier to just sort of adopt it, and with no friction whatsoever. And then the other piece that we have that we do quite well, and we have a couple of unique aspects or components in this category, is accelerating review. So everybody knows what email threading is and near duplicate grouping. But BrainSpace also creates something called a BDID, which allows you to intelligently sort the documents based on similarity. That is, when you're looking at a document, you can be guaranteed that in any subset that you're looking at, if you're sorting on that number, the document that preceded it was the most like it. And then we also have another mechanism called, that's really a representation of our clustering, and that's called the related set ID. And you can think of that as a near duplicate group that you've just opened the threshold of similarity a little bit wider on, and you can sort of evaluate the differences between the near duplicate groups. So really, from end to end, that's what BrainSpace is. It fits into these three different categories. So one of the most obvious workflows, and this is sort of how we'll sort of demonstrate the product, although I'm going to be focusing more on the features, is really a typical investigation. And they all kind of have the same things in common. You start with a little bit of information. And really the best thing to start with when you have just a little bit of information, maybe a person's name or a product name or a part name, is the concept search. Because the concept search, and the way we present it, we call it transparent concept search, is all about taking what you know and then seeing what the machine, the brain, knows. And when you plug a search in, we come back with a set of results and really a visual representation of the conceptual distance. So it helps with this idea of serendipitous discovery. And the idea there is that going from what you know to then expanding on that very quickly in the interface, you can kind of experiment with it. You can test out theories. And another major component of the user experience is we're doing a lot of the heavy lifting in memory, so the results are instantaneous. And that allows you to dynamically interact with the interface and check out the results and try things out. We'll actually go through a scenario. The way we cluster documents, the next step here, our cluster wheel, we've built it 8 years ago. And the first version of it really was, at the time, there was nothing like it. But the way that we organize documents is not like other types of visualizations that are similar. We do it based on lexical similarity. And there's the main reasons why we do that, the two that are worth noting. It gives you a sense of hierarchy. It gives you a sense of all the documents live at the middle of the wheel, and as you move out to the edges, the piles of documents become smaller and smaller, and the documents become more and more like each other. But we're combining this with one of our patents that is really all about the phrase detection, the concepts, the multi-word terms that have more meaning. And we take the top terms from each of those clusters and we label the clusters with those terms. And the idea is that it gives you the gist of what's in those clusters. You can very quickly look at something and detect whether or not it's going to be likelier to be responsive or relevant, or possibly noise. Things like fantasy football stand out, or junk like URLs, things like that are very obvious at the surface level. And you can just set them aside, not necessarily omit them or exclude them completely, but certainly prioritize them with a lower priority. So combining concept search and using concept search to find very unique and novel terms with our cluster wheel gives you this really powerful feature set that also allows you to establish context. So typically when you look at terms distributed on the wheel, you can see that the terms are existing in different types of documents because they're organized by the same types of words. So if you have a very novel concept that shows up on opposing sides of the wheel, that shows you that concept is in two completely different types of documents. And you can then start to understand, okay, in which context is this term I'm interested in valuable to me or relevant or responsive? And if I find that an exemplar, I should use that as a training document to build a classifier to make the whole system smarter. So we brought this whole experience together in the visual interface in a way that is just different. Once you've established context and you really want to kind of take this next step to understand who's involved, that's where we introduce this idea of entities, people and companies. And so we have a network graph, a communications analysis graph, that really shows you the network of communications between people, sort of how people are connected. So you analyze the parties that are involved based on your subset that you found using the first two visuals. Once you've found those people, you can then move back to our dashboard and filter based on metadata, things like dates and custodian names and file types. And all of that can be done dynamically. Ultimately, you're going to arrive at a set of documents, and if it's an investigation, that may be your evidence. If it's more of an exercise in accelerating review, maybe it's just a set of documents that are definitely the kinds of documents we want to find more of. You tag those, and you can immediately start building a CMML classifier once you've tagged a document. We find there's quite a bit of value, and it's much easier to start finding negative documents, and as you're finding negative documents, organically tag them as you're finding them, because that drops the floor. Every time we rank a document, the noise floor, sorry, every time we tag a document and we run the classifier, we update it, we're re-ranking the documents with a new ranking. And that ranking is something you can look at, and it will say this document is 70% likely to be responsive. And so you can use that to constantly re-rank and sort the data in a way that makes the most sense. So for a review, certainly makes the most sense to look at the more likely to be responsive documents first, and then hit the point in the workflow where you stop seeing responsive documents. And we have a number of different options there once you hit that fork in the road. So that's the investigation workflow. We also call it intelligence-minded to keep it a little bit more generic, but ultimately these are the steps that people are going through to find things in our product. Prioritizing review is something that obviously we do really well with Relativity. The idea is that BrainSpace is great at helping you make decisions on groups of documents, and starting with a concept search, validating the context, all of those same steps apply here, but we immediately will build a classifier as soon as we can. And if we want to start with keyword searches, by all means we can. And then we want to start feeding that into Relativity. So our integration with Relativity is you can basically connect BrainSpace to Relativity, pick a tag, and anybody that's creating or tagging with that tag, those decisions can be folded right back into the classifier. In fact, it can be set up on a schedule, and it can happen 2 times a day, it can happen once every hour, so it can be as dynamic as you want it to be. Thing to consider is that the ranking will change every time the classifier updates. So those are things that need to be considered. And unless the ranking is dramatically different, then there's really nothing to worry about. I mean, there's not much of a difference between something that's 75% likely or 78% likely to be responsive. But this process of ultimately using that rank to batch out the review is really powerful. And the process of taking what you've coded on a daily basis and folding it into the classifier is an iterative process that ultimately, IRF is the acronym. I don't know if anybody's heard that, Iterative Relevance Feedback. So that's what we're doing is constantly evolving the model. Predictive coding uses the same underlying technology, but ultimately with predictive coding or the TAR1 workflow, which we do support, and we do a great job of sort of surfacing all of the statistics that are occurring as this process happens. It really starts with your baseline statistics, right? You're saying, I want to produce or be able to produce 80% of the responsive documents, 95% certainty, give or take 5% margin of error. And so once you plug those statistics in, we'll give you that feedback every time you add training documents to the model. The key to remember, or the key to predictive coding is that the profile of the matter actually fits that, because predictive coding really does require a certain level of richness or responsive documents to exist in order for you to actually hit your goals. So we do support it, but the nice thing about the way BrainSpace is set up is if you get into the predictive coding workflow and you find that the richness just isn't high enough, you can quickly take what you've coded and fold it and just turn it into a CMML workflow and start using those coding decisions to rank the documents. Coding validation, if you've already got review that's been done and you've got decisions that have been made, you can take those decisions, build a classifier, and immediately know how consistent your review team was. It's a very powerful use case and very quick to get to those numbers. So we'll actually tell you what the consistency score is as soon as the model's built, and you'll be able to go through a process of actually looking at the mismatches and deciding, was it the reviewer that was right or the machine? At what point do we need to, or what decision do we have to make? Where does the overturn need to be made? And then of course, BrainSpace can be used for noise reduction. So it's an extension of an EDA or an ECA workflow. All of our visuals can be used to make decisions on documents, and at a high level, if you see something that's clearly personal communication or things like that, you can omit it or remove it from your review process. Okay. Talk a little bit about linear review accelerators. So I mentioned them earlier, but we have, of course, near duplicate grouping, email threading. We will mark inclusive or unique messages, intelligent sorting, which is the BDID. We also will detect exact duplicates based on content only. So that's something you can combine with standard hash methods of deduplication. The reason we remove documents or duplicates in BrainSpace really is to create a smarter brain, because duplicates can artificially increase the value of certain terms. Okay, so we'll jump into the product now. And I'm sorry, it is Enron, I know. I'm going to start with something a little bit different, and some of you may have seen this in the older version. So what we have actually done in this data set is we've built a BrainSpace data set on the entire Wikipedia site, 4.3 million articles. And something kind of interesting, it says something about us as a culture because you can see some of the standout themes on these clusters. Football, I mean, that's what we are, we're football. But at this level, with this many documents, the wheel's kind of telling an overly generic story at the baseline, right, at the root level. So remember what I said earlier, everything lives at the center. We take one step out, that's called a root cluster, and these root clusters are millions of articles large. But when we focus on something, and that's what we actually call this process, we did that, we built a focus on the term Apollo, that's where we can start to understand how powerful this can be at establishing context. So you can clearly see here, we have the Greek and Roman mythology topic, Apollo. We have the Apollo Theater. There's an Apollo record label, an Apollo school district. And then we start to see things around the aerospace, aircraft, Earth, and NASA, the Apollo space mission. And if we zoom in on that cluster, what we're actually doing here is expanding things dynamically. So as you drive out to the edges, we open the clusters up and show you more terms. But the terms here are coming from that process where we're actually recognizing, after we filtered out all the stop words and boilerplate and content, there's a lot of special sauce going on behind the scenes. But we actually surface the essence of the documents. And then we take the average document of the clusters and we display those terms. That gives you the gist of what's in that pile of documents. And this set of documents now that are specific to the space program, it's only 2,100. So I went from 4 million to this focus, which is about 40,000 documents that contain the word Apollo in the articles. And now I'm looking at 2,125 that are specifically talking about the space program. And I'm going to jump back to the dashboard just to touch on one of the other things we've added in the latest version. So one of the things that we're doing during the build process, or the generation of the data set, is we're actually plucking from the unstructured content entities. And so we have a series of entities that we're pulling out and creating these metadata fields. And they can be overlaid into Relativity and used for searching and filtering there as well. And just to kind of show you some of the power here, we've got emails, locations, money, nationalities. And for the space program, if I click on person, you can see we've got Neil Armstrong, Wernher von Braun invented the rocket. So all these things are surfaced, and they can be used as filters to further refine what you're looking at. So we like to use this example to kind of help people understand how our clustering approach is different. It's completely unique. We haven't seen anybody else do anything like this. And the reason that we do it is because we get the benefits of a concept search without having to group documents together. And when we combine it with this, we get this ability to establish context very quickly. So let's flip over to everybody's favorite data set and do a quick concept search so I can show you how these two things can be combined. So I'm going to search for, let me do, I'm going to try something different because I like to roll that way. No, didn't work. So I don't know if, I'm sure everybody knows this story. This was the acronym that Andrew Fastow, it's actually his family members' names, LJM. But if I immediately search for LJM, things like Black Bay, Price Return, Chuco, and Raptor come back. So it's obvious that Raptor is the thing that we all know was how they were hiding their debt in the Raptors. And when I do a concept search, the idea again is expanding on things based on what I know. So if I know LJM, I'm immediately going to see that Raptor is related. And now I want to take this slider here, which is really a representation of the relatedness, and I'm going to say, yeah, you know, that's something I want to explore. So I'm making it required. When the line turns green, that's basically telling the search that Raptor has to be in my results. But you'll notice that when I did that, the wheel changed. And what's happening here is the color is dynamically updating based on the volume of hits, the number of documents that exist with that term, and showing me on the wheel where those hits occur. So I can see that really it occurs everywhere. It's all over the data set. There are different documents here, and there's definitely things about the Toronto Raptors, which is obviously a different context. But you can see where the most prevalent or most the highest richness of hits for that term are showing up. When I actually look at a document, if I find something that's particularly compelling to me, I can quickly click on the little icon there and see exactly where that document lives on the wheel. Imagine every document has a spot, just like this one, around the wheel, almost like second hands on a clock. So that means if you find something, and you could use any mechanism for finding something in BrainSpace, or you can bring things in from Relativity and see what they look like in the focus wheel, or the cluster wheel. You can then go to that neighborhood and see documents that contain like words. And if I click on this little indicator here, it'll spin me out to the edge of the wheel, and I can take one step back in and look at that cluster that it lives in. And you don't necessarily have to open the viewer to see where a document's positioned. But you'll notice here that when I click on the cluster it's actually in, it's got a little N on there, and that's telling me it's a near duplicate. And one step back from the near duplicate or exact duplicate cluster, which is a pile of much smaller documents, so you're going to get much more descriptive labels, is the related set. And that's the same ID that we can use on the review side if we want to organize review based on the clustering in BrainSpace. So if I then go into this cluster, I'll see I can add that to my search, and I can get a much more targeted set of results that are based on the documents that live in that cluster. And we'll back that out. Now, combining the dashboard with the search results that we got from those first two steps, and we've done quite a bit of redesign here to the dashboard. We really wanted to maximize the amount of capabilities and really introduce a new visual that we're calling the term heat map. And that's this little color-coded thing down here. So there are two ways to understand what the heat map's doing. There's two ways that we're presenting it. Firstly, everything's driven by a timeline, right? So we are taking that and combining it with the term, or in this case, for the blue pattern we're seeing here, that's based on the document volume as well. So we can see all of these terms. We can establish things where maybe there are terms intersecting with each other that have a higher relevance. But we can, at a glance, we can see where there's more documents that have the terms that are in this map. We can also build custom lists. So you can take your top terms and plug it in here and actually see where the terms intersect with each other and how they're distributed over time. The second one that we're doing is actually, there's quite a bit more going on here. So this is called anomaly detection. So with investigations, oftentimes, if there's an event, there'll be a peak or a spike in certain terms that are being used around that event. And all we're suggesting here is that if you're going to start with very little information and you just have a general idea what's going on, if you look at this, you'll have a general idea where you should look first. And looking in those locations first will guarantee that you're probably going to see some type of, maybe it was an uh-oh moment or something happened around any terms that you've got loaded into the term heat map. So we can actually evaluate each one of these cells that is lit up a different color here actually ties directly back to a search, and we'll bring back that many documents in a search. So what I'm going to do is I want to take my Raptor search, and I want to actually see what Raptor's about in the highest distribution in hits over time in the year 2000. So I'm going to click on that, and now I want to really understand awesome. Let's just refresh that. Interesting. Can't do a demo without sometimes things going sideways. So yeah, that would normally bring back everything from 2000, but for some reason it's not working. But that's cool because this is also a really cool visual to look at with all the data loaded into it. This is called the communication analysis graph. It's also known as a network graph. And so the point of this visual is really to give you an at-a-glance understanding of the communication patterns that are occurring around, in this case, the Raptor search. So you can quickly establish things like who's involved, who are the pervasive communicators, who's sending more than receiving, who's CC'd more than to or a BCC. So you can very, very quickly get a lay of the land and understand who the key players are, who the key actors are in the matter. The other thing you can do is you can quickly pivot to a domain view, which will give you it's an easier to look at graph because there are typically less domains that are communicating. And so what we can see here very quickly are that Enron is, of course, the hub of communication. The circles are called nodes, and the size of the node is representative of the amount of inbound and outbound communication. But where it really gets interesting is in the lines, which are called edges. And I can very quickly get an understanding of what these two domains are talking about by just clicking on the edge. I'll get a top term sort of summary of all the things that are flowing back and forth. So you can imagine an investigation, if we use this mechanism and we've got a couple of people of interest and they're communicating with each other and we just want to really quickly get a lay of the land and understand all the things they're talking about, I can click on an edge, submit that as a query, and I can even then build a focus on that and get a very quick summary of all the things that those people are talking about. And you may see that they're just talking about fantasy football and this and that and a bunch of insignificant things, but then you will very clearly see if there's certain language that brings together communication in a way that just uses the same words, you'll see that pocket or that wedge in the wheel very clearly. So it's a really great way to summarize or get the gist of what two people are talking about. It's also really powerful for, and there's an unfortunate guy in the Enron data set that I had the pleasure of finding, and it's not appropriate to show it to you, but he was an HR nightmare. He's actually conceptually related to the term Miller time, which is a pretty impressive feat, I think. And when you build a focus on this guy, and all of his aliases collapsed into one node, which we can also do, at a glance, if I'm his boss, he's fired. It's because there's maybe one wedge that's sort of remotely about swaps and things like that. So he was mostly talking about football and then just propagating inappropriate emails. So this power of being able to really quickly establish, get an understanding or a lay of the land is hugely powerful in an investigation. But it's also powerful for speeding up review because it can help you prioritize the review. So what I'm going to do here is I'm just going to quickly focus on communication between Enron and Vincent and Elkins, and we'll add that to the query. One thing worth noting is that as I'm clicking on these visual artifacts, behind the scenes, we're actually generating a query that we're submitting to Lucene. So one of the benefits of keeping what we call our semantic space or brain outside of the index is that when we submit a search to the concept search, when we actually plug a search in, it goes to the brain, basically tells the brain what you're interested in, and then the brain submits the query to Lucene separately. So what's powerful about that is by keeping those two things disconnected, there's this sort of portable intelligence that you can take those same results and you can output them as a list of results and run that same search in Relativity or in any other tool that has search capabilities. So it's really powerful once we built this brain to take that and make it portable wherever you need to be, pulling back results that are consistent with what you're actually finding. So the fact that we're kind of pulling the hood up and letting you look at the search that's being executed to get these results, not only is it repeatable, but I couldn't build this search if I wanted to. I'm not that nerdy, but I'm pretty nerdy, but not this nerdy. I don't have to be a PhD to build this, is the point. So using the visuals, lots of complex things are happening behind the scenes, but ultimately it drives results. So now that I'm looking at just these two domains communicating, I'm going to flip over to my people view, and then I'm going to get a very quick snapshot of the people involved in communication about Raptor between those two organizations. And there it is. Now ultimately, once you've found your results, it's time to take action, right? What do we want to do with these? We want to build a classifier. So I found some specific documents. that represent what I would consider responsive or relevant, and I'm going to take my results and just apply a tag. Now I can use a tag that came over from Relativity, I can build a tag in BrainSpace, I can stay within BrainSpace through the process of building a classifier. The point is that it's very easy. All it requires is that a tag be created. So once I've got that tag, I can just go ahead and tag the documents. The other thing I can do is I can add these documents to a notebook. And a notebook is like a container that allows you to collaborate. So as you're finding things, you can be putting things in a notebook, tagging things for classification, but ultimately collaborating, right? So somebody could say, I'm going to take this whole half of the wheel or this segment of the wheel, and I'm going to look at these documents specifically around these topics, and I'm going to look for exemplars, things that are powerful and can help train the classifier faster. Another person can see that happening, and they can say, okay, well, I'm going to focus on this part of the wheel, and together when we'll be feeding the same classifier with our findings. So once you've got things tagged, let's talk about how easy it is to actually build a model. So we have a couple here that we've pre-built, and I'm actually going to focus on this one because I went through about 4 rounds of training to kind of show somebody's messed with my model. So really what I did here was a couple of different things. Started with one example, really this AIG fund document, which would have been at the top if somebody hadn't built that round. But the AIG fund document mentions Raptor, mentions that things should be hedged through Raptor, and there's about 7 exact duplicates of that document. And then what I did was I completely stopped focusing on finding positive examples. I said, you know what, now I want to find just a bunch of stuff to really drop the ranking for most of the data set. Because after I found that one document, I looked at the ranking, and documents all the way down to, I want to say 700,000 or so were ranked above 50%. That's not really that helpful. But by just going through this process of looking for negative examples, things that were obviously not responsive, in about 4 rounds using our visuals, I was able to build a focus wheel on everything that was 50% or higher, likely to be responsive, and then go around that wheel and just find obviously negative examples. But the goal really was to introduce diverse negative examples. So that accelerates the process of training a classifier because you're basically telling it all the things you don't want, and in doing so, it drops the ranking for more of the data set. So we went through a round where we did that, and then got my results, and then I went in and used one of our one of our methods for picking or selecting documents to help train the classifier. So at this point, I'm like, okay, not finding any more positive documents. I've looked at everything above the 50% mark. Now I want to use an algorithmic approach to going and selecting documents to help me train the classifier. So we have a couple of really unique ways of using not only the active learning algorithm. And is there anybody in the room? I'm just going to assume nobody knows what active learning is. I know everybody's talking about it, but I like to kind of put things in a way. I like to explain things to my mom, and I know if I can see that she understands what I'm saying, I'm like, okay, good, I can talk about this. It's just what we don't know. It's what we haven't seen yet. The model has a level of certainty based on what I've given it. It knows what I don't want. It's got a lot more of those examples, and it's got one example of what I do want. So it's going to go to the areas of the data where it doesn't know things. Then we're going to combine that with our clustering algorithm, which is going to give us a distribution of different types of documents. So when we combine those two things, what you're doing is you're streamlining this process of teaching the classifier because you're giving it the best examples to train the classifier faster. So we have 2 methods where we combine active learning with these diversity approaches. And the first one is the clustering algorithm, the same way we group documents in the cluster wheel. The second one actually uses a more advanced method, which is looking at the actual features, the concepts or the terms in a document, and it's picking the most representative document from that area. So those 2 things coming together in a way that ultimately what it does is just speeds up or allows you to get through the training process with fewer documents. So in a predictive coding workflow, this is very obvious, and that's what we're doing round by round. We're selecting 200 documents, but every round we're picking the best 200 documents to train the classifier. In a CMML workflow, it's really all about getting that distribution. So if we hit a point or a plateau in this graph where we're not finding any more positive examples, we have a couple of different options. We can say, I don't know, maybe we're done, maybe not. If we're not done or we don't feel good that we've seen everything, let's run a couple of rounds where we're pulling from all these areas we haven't seen examples from yet. After a few of those, we're going to start to get a lot more confident that, you know what, we're pretty good, at least on this classifier. So doing that is very straightforward. You just select the option you want to use. You select the size. And the cool thing about this is I found this out, I kind of stumbled onto it. We won't pull any more documents than we need to. So if we say, give us a fast active round, and it says, all right, I want 2,500, and it says, hey, I can do that for you in 1,300, it'll just bring back 1,300. I'm like, oh, cool, I don't have to do as much. It's awesome. So that's what I did here in the third round. Let me scroll down here. And I just want to quickly show you what I did was I built that round, and then I built a focus wheel on that set of documents. And the point there was, okay, now I want to see a summary of the diversity. And so I was able to very quickly then go through, and I just want to show you what that looks like. So we did it, there's the 50% or higher, and there's the fast active. And I quickly filtered out the duplicates. And now this is a representation of diversity on the remaining documents. At a very high level, I'm able to quickly see things. And again, remember, making decisions on negative documents, very easy to do. And you can see here there's some noise, a URL cluster. Those types of things are very easy to spot when you're taking this approach. So now that we've got all of this kind of figured out, let's say we want to take the classification or the ranking of documents and we want to apply it to a workflow everybody's comfortable with, email threading. So you can imagine everybody in the room understands the benefits of looking at just the unique members of a thread, right? Well, imagine combining that with a ranking of documents that are likely to be responsive. So you can very quickly do that. And we have a way to do a thread analysis in BrainSpace. And if I pull up my thread analysis here, and just grab a search. We're actually going to show you the hierarchy of the thread. So if you're looking at a thread and you're looking at it through the filter of a focus, that's only 50% or higher documents likely to be responsive, we'll actually leave out the documents that don't meet that criteria. So you can quickly make decisions on things that are more likely to be responsive in the thread, and that can easily be propagated over to Relativity. So you can, maybe that means the whole thread gets tagged that way, or maybe it means that just that branch of the thread gets tagged that way. The point is that it's very easy to do that, combine those two things. The thread visual is really all about giving you that sort of high-level view of the thread. It's thread analysis, and it's a little bit different than the way you would do a thread review, because it's ultimately about taking the documents that matter the most and applying the decisions that you've made to those documents either to the classifier, accelerating the process of building a classifier, or propagating those decisions over to Relativity, or maybe being more targeted with your tagging. All right. So I think I'm going to pause and just see everybody looking at me, and that's good, because sometimes this late in the day you can get some yawns, and you're either into this or you're not into this. But I'm curious to know, what do you think? Does anybody have any questions? Is this cool? We feel like it's cool. I feel like it's cool, but I'm a nerd, so. Go ahead.
I think I heard you say this. I just want to make sure. In terms of a control set, if you're just using it for prioritization, you don't need a control set.
Right. CMML, which drives not only what people call calling workflows, just iterating on that number, I think is probably not cool, because it gives people the impression that, well, 3.0 must be better than 2.0. So who's going to get to the next number first, right? It's just really, it's dynamic and it's iterative. Yeah, right. And that's why we say it to kind of get people to wrap their heads around what we're doing. So CMML can facilitate a TAR 2.0 workflow, but it's far more dynamic than that. I mean, you can learn as you go. You can iterate on that process, and you can use all these different, continuous multimodal learning is about taking all of these different inputs, the visuals, your decision making, all of those things, and folding it into one cohesive set of features. So, go ahead.
You talked about your integration with Relativity and how you can tag either or.
Yeah.
So is it I guess, supported workflow that you can have? I guess this is another question as far as whoever's training the tool to prioritize documents for that continuous active learning. Is it okay to have multiple subject matter experts? And if so, is there any kind of coding consistency check?
Yeah, every time we fold new documents into the model, we're going to tell you what the consistency is. So if two people disagree, you'll be able to take action on it right away and course correct as you're building it.
Okay.
Yep.
So let's say that they're coding in BrainSpace. You can set up
Yeah.
have, like, say, auto batching set up if you have a search, above some threshold?
Yes, absolutely. And it's completely automated. So the process of connecting a tag, I just wanted to pull this up. This is looking at a list of tags that exist in Relativity. So if I pick one that I want to use and hit connect, that will now be a BrainSpace tag. We've just created the BrainSpace tag in BrainSpace just like that. And it's coming from the Relativity tag, and it's now connected. So you can see there, disconnect tag if I want to disconnect it, and I can pull it right here if I want to. Once I've got that generated, I'm just going to take a step back here. In the classification interface, when you've got a connected tag, you can just pull it, or you can set it up on a schedule. You can update it here, or you can go ahead and plug in your date and time. Maybe it's after hours. So this process is, once you have this established, that's it. You kind of hands off. You just let it do its thing. It pulls the tags from Relativity, feeds it to our server. We update the model, and write the ranks back over. So that's what's cool about this, is because you can be doing it based on review decisions, but you can also be in parallel looking at things in BrainSpace, making other decisions, and fold that into the model as well, and that can of course influence the ranking. So it's really versatile. This is the automated way to do it. You can also do it through a notebook, and I didn't talk about that, but once you've established or built a notebook, you can come in here and hit the sync button, and you can just sync the notebook to a field in Relativity. So those are the, go ahead.
So all documents that are in that notebook will be then tagged to,
Whichever one you choose, yeah.
is that a certain field type available in there? Is it a
What is it, a multi-choice, I think? I'm not like a Relativity pro or anything. But yeah, I think it is. It's a tag field, and I believe it's multi-choice or single choice. We have, really it's worth mentioning how we integrate with Relativity. So the first point of integration is how do we get data in from Relativity. So once you have our environment connected to Relativity, that's through what we call a connector, we are just reaching into their database and pulling all the text and metadata out. It's worth mentioning we don't do anything with native files. We just process text and metadata. So things that you would normally have to read, that's where we work our magic. So we build the data set, we build the brain, we build the index, we overlay all of these additional fields, and some of them are redundant. Relativity has email threading and all those things. So we have our BrainSpace version of all those things. Those get overlaid in. And then once you're done with that step, it's all about syncing work product. So you can do it through notebooks, you can do it through connected tags, and you can do it through safe searches and all the things that you build in BrainSpace. Anything you do in BrainSpace can be updated in Relativity via a tag, and you can take action on those documents at a more granular level. So.
as far as email threading goes, or the email threading results, is that something that can be imported to Relativity, or is that
Yeah.
something that exists?
Yeah, no, all of our email threading fields get overlaid in. Anything that you do in the thread analysis interface, any tags or any actions you take there, all of that can be synced over to. Yeah.
Are you actually creating safe searches in Relativity, or are you just,
No, there are safe searches. They're Lucene.
gotcha.
Yeah. But you can take a safe search from Relativity, tag the documents, and then update it, pull those over. And we can push or pull work product. Yeah, tags. Any other questions?
For your concept clustering and focus wheel, is it still the case that a document can only appear in one cluster even if it has multiple concepts?
Technically, it can appear in one position on the wheel. It travels or intersects through multiple clusters, but a document is going to be more like the cluster of the documents that are in the position that it's in. So we have to make a decision on where those documents live. We make the best decision based on, of course, the like words that exist in the document.
So there's a ton of compound documents though, right? That can be about many different things. Do you consider allowing documents to sit in multiple places?
Well, the concept search gives us the ability to relate things that way. The cluster wheel has a very specific purpose, right? It's establishing context. It's being able to see the hierarchy, see where those, so being able to kind of navigate through the visuals to find the more targeted subset. So when we start, we've talked about it before, it starts to get very, you kind of have to follow the rules, right, of organizing the data that way. And I don't know if anybody else from BrainSpace wants to chime in. I know there's a backstory there. Because we've had that question a number of times, like why can't we have, documents are like many documents, so.
And the problem is it becomes multiplicative, right? You could end up with an infinite table of clusters and documents very important document. Concept search is a really nice job of identifying the different points of the wheel that may have multiple kind of concepts included. And that's the reason why we also have the ability to spin back up a wheel based on the result of concept search. Then it gives you kind of spins those out.
That is a great point. I mean, that is a really great use case for the focus. So building a subset. So if you find the types of terms that you are interested in, you build a subset or a focus of that, you'll get a much more targeted, specific set of results.
If you have multiple foreign languages in your workspace, can you categorize them in one project, or do you need to set up multiple?
No, you can do it in one. And I didn't even talk about that. We have a very robust language identification and tokenization set of features. So we can also handle mixed languages within a document. So the way that we're recognizing that things are conceptually related, it's really just patterns that are repeating themselves. So if we tokenize something and we can see that there's different languages there and they show up in proximity to each other over and over again, they will be conceptually related. Yeah. So we identify and also all of the visuals, everything. In fact, I'll give you a little teaser here. This is the Wikipedia data set built with Arabic. I should have learned Arabic when I was a kid, but I didn't. My dad tried to teach me, but I was like, the whole right to left thing threw me off. As the scores change? Yeah, we're keeping track of it, and it's very easy to do that on the relativity side, but we are keeping track of that sort of evolution. So there's round statistics, the consistency reports generated, and there's something called the predictive report, which is the entire corpus of data getting updated with the rank. So at any point that you've built, you can go to each of the rounds individually. Oh, there is no classifier in that data set. I'll just quickly show you what it looks like. So if I wanted to go to the set of documents that was tagged in that set, I can actually go directly to that just by clicking on the analytics button. And those are the two documents I added in that round. And that round has its own consistency report. So you would really want to focus on times where the rank maybe changed dramatically, like it went from 80% to 20%, what happened. Any other questions? How are we doing on time? 10 minutes. All right, cool. Thanks for chilling with me. You guys were cool. I was a little worried because the end of the day is always rough. People are a little tired. They've been through a lot. But thanks a lot. You've been a great group. Good questions.